Welcome to The Explainer. Today, we're going to talk about the physical properties of the electric current. You know, it's that invisible force that powers literally everything in our lives. It sounds super complex, I know, but trust me, by the end of this, you'll see it's actually as simple as a river flowing downhill. Okay, so let's just dive right in. To really get a handle on how electricity works, we're going to use this simple but really powerful analogy. I want you to picture an electric circuit. All those wires, all those components. I want you to think of it like it's a river system. So what's the actual water in this electric river of ours? Well, it's a massive flow of these teeny tiny particles called electrons. And when all these electrons start moving together in the same direction through a wire, boom, you've got yourself an electric current. Now, that big rush of electrons has a proper name, electric current. And understanding its three core physical properties is the absolute secret to controlling everything from your phone to your TV. So, let's explore the three main rules that make our electric river work. First up, we've got the flow itself. This is the most basic property, and scientists call it current intensity. It's basically asking the question, how much electricity is actually on the move here? So, let's go back to our river. Is it a huge, raging torrent of water, or is it more like a gentle little trickle? Well, that's exactly what current intensity is all about. It measures the sheer number of electrons zipping past one single point in a wire every single second. And what's really cool is how we actually measure that flow. Current intensity, which we represent with the letter I, is measured in something called amperes, or you've probably heard of them as amps. It's really just the quantity of charge, Q, that flows over a period of time, T. So yeah, more charge in less time, that means you've got a much more intense current. Okay, let's move on to our second property, because this is where it all starts to connect. We have a flow, sure, but a river doesn't just, decide to flow all by itself. Something has to get it moving. So what's the force behind it? Think about it. Water only flows downhill, right? It needs a slope to give it that push. Well, in the world of electricity, this slope or push is called potential difference. It's the electrical pressure that gets those electrons up and moving in the first place. And that push, which we represent with a V, is measured in volts. You've definitely heard of volts. It's literally the amount of energy needed to move a certain amount of charge. So the takeaway here is super important. If you have no push, you get no flow. Simple as that. All right, so we've got our flow, the current, and we've got the push that creates it, the voltage. But let's be real, not every river flows through some perfect, smooth channel. There are always obstacles. And in an electric circuit, those obstacles, the rocks, the fallen trees, are known as resistance. It's basically anything that opposes the flow of electrons. Some materials, like copper, they're like wide, clear channels that just let electrons cruise on by. But others, well, they put up a bit of a fight. We measure this electrical friction in a unit called ohms. And the key thing to remember is pretty intuitive. Just like a really long, narrow, rocky riverbed creates more of a headache for the water, a longer or a thinner wire creates higher resistance for the electrons trying to get through. And now for the big aha moment where it all just clicks into place. These three things, the flow, the push, and the obstacles, they aren't just doing their own thing. Nope, they are all connected by one simple, really elegant, universal rule. It's this beautiful little cause and effect relationship. You've got the push, that's what starts everything. That creates the flow. But that flow is always being held back or limited by the obstacles. It's like they're in a constant dance together. And this right here just illustrates that relationship perfectly. It's totally intuitive. If you increase the push, the voltage, you're going to get more flow, more current. Makes sense. But if you increase the obstacles, the resistance, you're naturally going to get less flow. This amazing relationship is known as Ohm's law. And that simple little formula, V equals I times R, is the fundamental equation that runs pretty much every simple electrical circuit that exists. It's the golden rule connecting these three physical properties. So, why should you care about any of this? Well, think about your phone charger. The voltage, that push coming out of your wall outlet is huge. It's way too much for your phone's delicate little battery. That big block on the charger is a transformer, and it's basically a piece of genius. It acts like a dam, taking that massive push from the wall and turning it into a gentle little stream that your phone can handle, all without frying its battery. So there you have it, the flow, the push, and the obstacles. With just the simple idea of a river and the golden rule of Ohm's law, you now have the tools to understand that invisible electrical world that's all around us. So, what kind of everyday electrical mysteries can you solve now? Thanks for joining me for this explainer.